Hello students, in this revision program we will start with the chapter atomic structure, right? Firstly, in a different manner, instead of again learning with the synopsis, we will start with the numericals or from different models, right? See, this is a question given. The value of 1 Einstein of radiation having a wavelength of 30 nanometer. Usually, when wavelength is given and energy is asked, okay, what's the formula we use? E is equals to hc by lambda. Even for this question also, majority of students will use the same equation. When wavelength is given, energy is asked, majority of students will follow this line. But you will get a wrong answer. Okay, and moreover, among the options, the first option will be given with the option or with the value which we can get using this relation. In that way, they will misguide the students also while setting the paper. You are getting? Once again, I am repeating. This is the question given. When Einstein means energy, right? Of radiation having wavelength. Energy is asked, wavelength is given. Immediately, a normal student will go to this relation. If you solve, you will get a wrong value definitely, because this is not the relevant formula for that. This formula is basically correct, but not suitable for this question. First of all, you should understand the word Einstein, 1 Einstein, right? What's the meaning of 1 Einstein? Yes, first you make a note of that one. 1 Einstein is nothing but energy of 1 mole of photons. Is nothing but energy of 1 mole of photons. Okay. In E equals to h nu, you know that h nu is energy of 1 photon. But 1 mole of photon means Avogadro number of photons. You are aware of the point. So, E is equals to Avogadro number of photons. This is the relation we have to use now. You got it? That h nu stands for energy of 1 photon. But Einstein is nothing but energy of 1 mole of photons. That's why Avogadro number of photons I am calculating. So, on substituting here, see, 6.023 into 10 power 23 stands for Avogadro number into 6.625 into 10 power minus 34 joule second into, this is nu is equals to c by lambda. We can use that substitution. See, velocity of light 3 into 10 power 8 meters per second whole divided by 30 nanometers. 30 nanometers. On substituting and simplification, see, this is 6.023 into 6.625 into 3 into 10 power 23 and 34. It is 10 power minus 11 and 10 power 8 and 10 power minus 11, 10 power minus 3 divided by joules divided by 30 nanometer means 10 power minus 9 meters. Even meters is also cancelled during this simplification. Now, this simplified value will be 3.99 into 10 power 6 joule per mole. This will be the ring left. So, what's the nearest value? 3.99 into 10 power 6 joules per mole. This is the option. So, in this way, instead of blindly going or going in a hurry way, you just notice the word given. Okay. So, this is one question we have discussed. Understood? Right? Let us see one more question. Right? This is the question. Right? A source of light having wavelength lambda. Some light radiation of wavelength lambda is falling on the screen. Right? A source of light having wavelength lambda ejected a photoelectron. See, from the screen, photoelectron is ejected out. We studied the concept photoelectric effect, right? Electron is ejected out by the incidence of light of wavelength lambda, and the kinetic energy of that ejected electron is 1 electron volts. And the kinetic energy of the ejected electron is 1 electron volts. On irradiating the same metal screen, when irradiated again with a different wavelength lambda by 3, ejected photoelectron possesses kinetic energy 4 electron volts. Two cases. In both the cases, the common point is work function is similar. Work function is similar. So that work function is, this is the question given, right? Now let us see. This is the formula for photoelectric effect. H nu means energy of incident photon equal to threshold energy plus kinetic energy, right? H nu equal to H nu naught, which is also called as work function plus kinetic energy. I substituted this with Hc by lambda equals to work function plus kinetic energy. Now use this equation for case 1 by the for the incidence of light of radiation wavelength, right? Case 1, Hc by lambda equals to W plus kinetic energy is given as 1 electron volt, right? Similarly, case 2 is Hc by lambda by 3. What's the second case wavelength? Hc by lambda by 3 is the wavelength, is equal to work function remains same plus kinetic energy of the ejected photons is 4 electron volts. Now, simplifying these two equations, we are getting work function as 0.5 electron volts. Understood? So, this is second question. Okay, this is our next question. If lambda naught is the threshold wavelength of a metal, you know what's meant by threshold wavelength, the minimum wavelength required for the ejection of an electron, right? For a photoelectron emission, okay? If the metal is exposed to a light of wavelength lambda, its threshold wavelength is lambda naught, wavelength of the emitted radiation is lambda, then velocity of the ejected electron will be, it's given, velocity of the ejected electron is given as something, 2h by m into lambda naught minus lambda into k. In such a case, find the value of that k. This is our question, right? Once again, a radiation is falling on this metal screen with wavelength lambda. Screen's threshold wavelength is lambda naught to eject an electron. Velocity of the ejected electron is expressed in this way. V is equal to 2h by m into lambda naught minus lambda into k. Then what is k? These are the options given, right? Now let us see, we have photoelectric effect expression as incident light photon. Incident photon is equal to threshold frequency or work function plus a kinetic energy of ejected electron. So on simplification, h nu minus h nu naught is equal to half mv square, kinetic energy formula. Nu is equal to c by lambda. By taking hc common, 1 by lambda minus 1 by lambda naught equals to half m into, substitute the velocity expression given in the question, whole square, right? Now on cancellations, we are left with the term k equals to c by lambda naught. K equal to c by lambda naught. Now our k answer is option C, right? This is next question, right? So this is our next question. The potential energy of electron in hydrogen atom. See, luckily hydrogen atom, usually one electron species will be given. Potential energy of electron in hydrogen atom is something, minus 6.8 electron volts given. Indicate in which excited state. See the question, in which orbit? They are not asking directly the orbit. In which excited state? Orbit only, but not the electron in the ground state, electron in the excited state. In which excited state the electron is present? For answering this question, we should be aware of the relation. Total energy equals to kinetic energy plus potential energy, or minus E equals to E minus 2E. So we have to remember all these forms, right? Now from these two, total energy and potential energy, we can take one relation. Potential energy is always 2 times of total energy. Potential energy is 2 times of total energy. Now we are given with potential energy as minus 6.8 electron volts equals to 2 times of total energy. Then total energy is minus 3.4 electron volts. We got the value. Now from this point onwards, we can solve the question in 2 ways. One is the regular systematic procedure. Energy is equals to minus 13.6 into z square by m square. So energy is given as minus 3.4 equals to minus 13.6 into 1 square by n square. We have to find that n value, right? So n square equals to 4, n is equals to 2. Orbit number here, n is orbit number. To confuse us, sometimes the paper setters may give the first option as second orbit. As immediately students are getting 2, immediately they will look after the 2. Where is 2? But look at the question, it is asking not the direct orbit. In which excited state? Second orbit is which excited state of hydrogen? See, electron is in first orbit. Electron is in first orbit, like this, 1, 2, 3, 4, so on, electron is here. If the question is find the orbit in which electron is present, means you can think in a different way. But here, excited state it is. Excited state means these are all the excited state other than one. So which excited state it is? First excited state, second excited state, third. This is the way, no? So electron is in second orbit means that is the first excited state of hydrogen electron. So answer is first excited state. Understood? Other than this, there is another way. There is another way. Like this is the nucleus of hydrogen. Energy of first orbit is minus 13.6 electron volts. Second is minus 3.4. Third is minus 1.51 electron volts. Fourth is minus 0.83 electron volts. In this way, if you remember these 3-4 values at least for hydrogen, you can directly answer it as get the value as second orbit. Second orbit is the first excited state for hydrogen. So in that way also, the excited state is first excited state. Understood? So this is the explanation given for this question. Right? So this is our next question. In hydrogen atom, we are asked to find out the kinetic and potential energies in electron volts. In which orbit of hydrogen? Third orbit of hydrogen. Third orbit of hydrogen. The kinetic and potential energy in electron volts of an electron present in third Bohr orbit in hydrogen are, what are the options we have to find? So immediately we have to come to the relation. Energy of electron in nth orbit can be expressed as En equals to minus 13.6 into z square by n square. Minus 13.6 into z square by n square. Now E3, energy of electron in third orbit equal to minus 13.6 into hydrogen atomic number is 1 square by orbit number is given as 3 square. On simplification, we got this value, right? Even we can get this value, energy of third orbit in hydrogen, directly from the previous discussion. In the previous question we did. Now, this is total energy. We have a relation total energy equal to kinetic energy plus potential energy, right? So, if total energy is minus E, kinetic energy is E and potential energy is minus 2E. Okay, this part you have to remember like anything. So, when compared with total energy, kinetic energy is negative times. So, kinetic energy is minus of total energy. See, kinetic energy is minus of total energy. So, kinetic energy is minus of minus 1.51 electron volts. Potential energy is minus 2 times of kinetic energy. When this is kinetic energy, minus 2 times of kinetic energy is potential energy. Right? This is another model. Means on every relation, we are doing one question. Right? So, our question is, what is the frequency of revolution of electron in second orbit of hydrogen? Frequency of revolution means number of revolutions per second. Usually, number of revolutions per second can be calculated as a ratio of velocity by circumference. Okay. Velocity by circumference. So, number of revolutions equals to, on substituting these relations, 6.66 into 10 power 15 into z square by n cube. On substituting the values, we are getting 0.8325 into 10 power 15 revolutions per second. Right? This is the answer. Right? So, this is our next question. What is the ratio of time periods T1 by T2? What are those times in second orbit of hydrogen to third orbit of helium? So, time taken for revolution in second orbit of hydrogen to time taken for revolution in third orbit of helium plus. First of all, what's the formula for time taken for one revolution? In seconds, time taken for one revolution is equals to circumference by velocity. Right? Circumference formula is 2 pi r and velocity formula we know 2.18 into 10 power 8 into z by n. On substituting those terms, just now we did the relation reverse. So, I reversed that formula 1 by 6.66 into 10 power 15 into n cube by z square. Reversed. Now, time taken for one revolution in second orbit. This is number of revolutions and this is in which orbit? One revolution in second orbit of hydrogen equals to this constant value into orbit number is 2 cube by atomic number of hydrogen is 1. Similarly, time taken for one revolution in third orbit of helium plus, orbit number is 3 and helium atomic number is 2. Now, the ratio of these two time is time taken ratio in hydrogen second orbit and helium plus third orbit is, on dividing these two things, we are getting 32 by 27. So, our option is 32 by 27, right? So, the next question is, the ratio of radius difference between fourth and third orbit in hydrogen atom and lithium plus 2 ion respectively is radius difference between fourth and third in hydrogen, radius difference between fourth and third in lithium 2 plus ion we have to calculate, and their ratio is asked as a question. So radius difference between fourth and third in hydrogen is 0.529 into n square by z. Formula 0.529 by z, if you take common, this is the value. R4 minus R3 in Li2 plus is 0.529 into n square by z. Okay. Now ratio of these two will be 3:1. Okay. See, by practicing several models like this on each and every relation, we can get good hold, right? This is our question, right? Okay. This is the current question. In a collection of hydrogen atoms, all electrons are jumping from fifth orbit to ground level. Finally they are coming to ground level, directly or indirectly, directly or in an indirect manner, without emitting any line in Balmer series. That's the condition given. See, without emitting any line in Balmer series. Understood? Now, with respect to this, how to answer? Check it once. With respect to this, how to answer? See, 5 to 1. Usually, when electron jumps from fifth orbit, 5 to 1, 5 to 1, 5 to 4, 5 to 3, 5 to 2, 5 to 1. That 5 to 2 is missing. So, fifth orbit to second orbit is missing here. The green line is missing. Whatever the green line I am writing, that is missing. Similarly, from fourth to first, how many lines are possible? 4 to 3, 4 to 2 and 4 to 1. And from third orbit, how many lines are possible? 3 to 2, that is missing, 3 to 1. Okay. And when electron jumps to second orbit, 2 to 1 also possible, which is now not occurring because electron is not at all entering into second orbit. So totally how many lines are missing? 1, 2, 3, 4 are missing. Then how many are possible? 1, 2, 3, 4, 5, 6 red lines are possible. Right? So answer should be 6. If you answer the question in this way, okay, you may get the answer directly. But usually for these competitive examinations, teachers insist to follow shortcuts, and students also do follow usually. If it is a shortcut method, alternate method, total number of spectral lines is equal to n into n minus 1 by 2, you know that. That is 5 into 5 minus 1, 4 by 2, 10 lines. Totally possible lines are 10 lines. And how many lines are possible in Balmer series? Number of spectral lines in Balmer series is eye level minus, Balmer series number is 2. So 5 minus 2, 3. Students will stop here. 3 lines are missing. Out of 10, 3 are missing. 10 minus 3, 7. If they follow shortcut, sometimes in a hurry they may miss one point. 10 minus 3, 7 lines are possible, means again from second to first orbit also one line is not possible, no? So 2 to 1 is also missing. So out of 10, totally 4 are missing. So number of lines possible are 6 lines. Okay, this is the way to solve this question. Right? This is our next question. The energy of lines 1, 2 and 3, 1, 2 and 3 are given as E, 4E by 3 and 2E respectively. Means E, 1.33E and 2E. A photon of wavelength lambda is emitted during a transition from 3 to 1. When an electron jumps from 3 to 1, okay, the emitted radiation is having a lambda, wavelength lambda. Similarly, when an electron is jumping from 2 to 1, its wavelength lambda will be what? This is our question. So that lambda we are finally determining. Okay. Now see, when electron jumps from 3 to 1, wavelength is given as lambda. Energy difference between 3 to 1 transition, where is the 3 and 1? 2E minus E, it is E. Right? Similarly, when an electron jumps from 2 to 1, what is the wavelength asked? So lambda, we have to determine that lambda. This lambda is question mark. That lambda we have to find. And energy difference for 2 to 1 transition, E 2 to 1 is 1.33 E minus E. It is 0.33 E, means it is E by 3. Right? Now, energy difference for 3 to 1, E is equal to Hc by lambda. For 3 to 1, what is the energy difference? E equal to Hc by lambda. Or from this, lambda equals to Hc by E. We can rearrange that. Similarly, for 2 to 1 transition, energy E 3 to 1, 2 to 1 equals to Hc by lambda 2 to 1. So, what is energy difference for 2 to 1? E by 3. We determined here E by 3. E by 3 is equal to Hc by lambda 2 to 1. Lambda 2 to 1 equals to 3 Hc by E. But we have Hc by E as lambda. So, lambda 2 to 1 is equals to 3 lambda. 3 times of lambda, because Hc by lambda is determined as Hc by E. Hc by E is lambda. Hc by E is lambda. So 3 lambda, right? This is another question. An electron in hydrogen atom in its ground state absorbed an energy which is 1.5 times more than the required energy. An electron in hydrogen atom in ground state absorbs 1.5 times as much as energy required, minimum required for it to escape from the atom, right? Suppose if its energy is 13.6 minus 13.6, it absorbed 1.5 times of minus 13.6, like that. Then what is the velocity of the emitted electron? So velocity means velocity is equal to, from kinetic energy formula we can use. This is the best method. Kinetic energy is half mv square, velocity equal to root 2 ka by m. But for this, we need to find out kinetic energy. This is the shortcut. We have total energy equal to kinetic energy potential energy. If you know the total energy, obviously you can find out kinetic energy, because it is minus of total energy. Kinetic energy is minus of total energy. Total energy is 1.5 times of energy of electron. Like total energy is 1.5 times of what is energy of electron in joules? 2.18 into 10 power minus 18 into z square by n square. Using this relation, we can find out total energy, from which its negative values, negative minus multiply with minus, will get kinetic energy, because total energy is expressed in negative sign, kinetic energy is expressed in positive sign. So this kinetic energy calculated, we have to supply in this formula. Velocity equal to root 2 ke by m. On substituting the values, we will get 1.54 into 10 power 6 meters per second. Be perfect in the calculation. Okay. So this is the answer. This is the next question, right? Hydrogen atom is exposed to electromagnetic radiation of wavelength 1025.6 angstroms, right? And excited atom gives out induced radiation, means electron is excited, and jumping back to the ground state, that induced radiations were also given, it's given. What is the minimum wavelength? Means maximum energy. Maximum energy means high level to low level. Minimum wavelength means maximum energy. Maximum energy means high level to low level. What is the minimum wavelength of these induced radiation? Right? Now, minimum wavelength means maximum energy. Maximum energy from highest possible level to lowest possible level. 3 to 1 we have to find. Now, how to solve this sort of question? This is the shortcut. E is equal to Hc by lambda. This is the shortcut. Energy in electron volts equal to 12,400 by lambda in angstroms gives us energy in electron volts. Understood? Now 12,400 by lambda in angstroms. This is in angstrom. Okay. Now 1025.6 gives us 12.09 electron volts. Got it? Now this energy value is nothing but difference between first and third. I already told you to remember the 3-4 energy of fourth orbit is minus 0.84. Even this also you remember. These 4 energy levels you have to remember for hydrogen at least. Understood? First orbit is minus 13.6. Second orbit is minus 3.4. Third one is minus 1.1. These two are 10.2 electron volts. And these two are 12.09 electron volts. That difference we have got here. So this energy difference is nothing but 3 to 1. Now electron is in third orbit. We got the point. Understood? Now when electron jumps from 3 to 1, what is the wavelength for the corresponding radiation? Lambda for 3 to 1 transition is Hc by delta E, because delta E is equal to Hc by lambda. That's right. So delta E equal to 1240 by lambda in nanometer gives us a energy in electron volts. This is, if it is 12,400, this is in angstroms. If it is 1240, this should be in nanometers. Now 1240 by delta E, on reversing this expression, we got lambda for 3 to 1 transition as 102.6 nanometers, right? This is the solution for the given question. This is our next question. See, the wavelength of an electron accelerated by by a potential difference of 500 volts is wavelength and potential difference. What's the relation? Immediately we should get lambda equal to h by root 2 m into potential difference into charge. But let us go through that small derivation part also. De Broglie wavelength lambda equal to h by mv. From kinetic energy expression, velocity equal to root 2 ke by m, and substituting this expression over there, lambda de Broglie wavelength lambda equal to h by root 2 m ke. But kinetic energy is product of charge and potential difference, right? Charge and potential difference instead of kinetic energy. Now this potential difference is given in the question, 500 volts. Charge of electron is, we are aware of that, 1.602 into 10 power minus 19 coulomb. Coulomb volt is charge, right? Now mass of electron is 9.1 into 10 power minus 31 kg. H value is Planck's constant. See, by substituting these expressions and simplifying, so we have to get an approximation. Don't stick on to the calculation part. We have to get an approximation, like 9 2s are 18. 18 into 1.5 times 18 plus 9, nearly 27. 27 into 5. Like that, we should get an approximation, 27, 5. And it's a square root value also. Nearly, by looking at the options, we can get an approximation, right? This is the solution for the given question. Yes, right? So this is our next question. It is about spin multiplicity. Spin multiplicity of p sub shell or p sub level with configuration. See, 3 unpaired electrons is. So whenever this sort of question is given, spin multiplicity means 2 into capital S plus 1. 2 into capital S plus 1. What is this capital S corresponds to? It is sum of the spin of all electrons. What are the electrons? See, the rest of the electrons are paired. It means when the electrons are paired, plus half and minus half, they are becoming 0, net spin. But for these 3 unpaired electrons, either plus or minus half is to be considered, neglecting the sign, half and half and half. 3 electrons, 3 into half, 1.5 is the capital S value, right? Now spin multiplicity equals to 2s plus 1, 2 into 1.5, 3 plus 1, 4. So this is the solution for the given question. Understood? So this is another model, matrix matching or match the following. Match the first column with second column. Magnetic momentum. Magnetic momentum, usually what's the formula we use? Magnetic moment, sir, I learned a formula, root n into n plus 1 into h by 2 pi. But there is no such formula here. How to answer? This is the immediate question a student will get, right? So when magnetic moment question is given, this is the formula a student will get immediately. Student will strike, right? But as there is no such relation, we have to recap something. What is that? See, here just now we discussed what is capital S corresponds to sum of spin of all unpaired electrons. Sum of spin of all unpaired electrons. That is, suppose if there are n unpaired electrons and half is the spin of each, capital S is n by 2, no? If you substitute this n by 2 in that formula, root of s into s plus 1 into h by 2 pi. Substitute s with n by 2, root of n by 2 into n by 2 plus 1 into h by 2 pi. What is this? On simplification, n by 2 into h by 2 pi means, so on simplification you are getting root n into n plus 1 into h by 2 pi. Right. So this is what we are going to get. So this formula corresponds to magnetic moment. Okay. And then spin angular momentum of an electron is root n into n plus 2 Bohr magneton. Root n into n plus 2 Bohr magneton. It's a direct relation. And angular momentum of an electron in an orbit is given with the angular momentum is given with nh by 2 pi. MVR is equals to nh by 2 pi, and orbital angular momentum is root L into L plus 1 into h by 2 pi. So in this way, sometimes they may give this matrix type of questions where we have to recap the relations, right? This is the suitable explanation for this question. So the rest of the questions on other subtopics will be sent as worksheet, and our next class will be on chemical bonding, right?